Welcome to the session of Big Data and Hadoop. Before understanding what is Hadoop is, we'll understand what is Big Data is all about. Now, Big Data has become a buzzword in the IT market. Everybody is looking at or looking forward to learn Hadoop. Not only the students, the working employees as well. Not only the working employees, even the companies are looking at Hadoop, and every company, who are dealing with data or huge amounts of data dealing with by the companies are looking at migrating themselves to Hadoop. So, before we understand what Hadoop is, what do I call Hadoop? Hadoop, do I call it as a language? Do I call it as a technology? Do I call it as a framework? So, before we get to learn what Hadoop is, let us understand what is the relation between Big Data and Hadoop. What is the relation between Big Data and Hadoop? What is that making us to understand whenever we speak of Big Data, what is this making us to understand why we wanted to learn Hadoop? So, there is a relation between Big Data and Hadoop. So, before we define what is Big Data, what is Big Data, first of all we will understand what is data. Before I understand what is Big Data, I will understand what is data. So, when I say what is data, anything which is not processed can be called as data. Any data which is not processed can be called as data. So, anything which is raw, which is not processed can be called as data. That means, when I process data, as we all know the definition of information, when I process the data, what happens? I will get some information. So, there is a relation between data and processing and information. So, data when processed, which gives me information, that is the simple definition of data. Now, the question comes is, now what is Big Data? What is Big Data? So, when I say what is Big Data, so lot of people say that any data which is very big can be called as Big Data. Now, the question comes is how big? Now, so let us see the definition of Big Data. For example, I want to quote you an example here. Now, for example, I have a mobile phone. Now, everybody is nowadays talking about the data is because everybody started using different electronic gadgets to store data. Now, if you have a mobile phone, what is the first thing that you would see? What I would see is how much data that I can store on that mobile phone and how fastly that I can process this data from this mobile phone. Or let us say if I wanted to buy a laptop, the first thing and the foremost thing that I look at is the hard disk capacity and also the processor speed. So, what is the speed of the processor or how much data that I can store on my laptop. So, they are actually runs in parallel. The more hard disk capacity that you have, the more processor speed that you have, then you call it as a very big system or very good system. So, when I say what is Big Data, how big data is, the data is my question. So, I was just quoting you an example. If I have a mobile phone, now in this mobile phone, what I can do is I can store, let us say 500 MB of file. So, I have a mobile phone in which I can store 500 MB of file. So, now I got a project. Now, let us say I got a project or one of my friends come in and say that you have a movie file that which actually is equal to 1 TB. Please download on your laptop or on your mobile phone. So, obviously, the whole capacity of mobile phone is 500 MB, but the capacity of a movie file is 1 TB. So, obviously, 1 TB cannot be downloaded or processed on my 500 MB of mobile phone. So, that means what is my infrastructure, my existing infrastructure is not supportive to that particular file. So, for my mobile phone of 500 mg, that 1 TB becomes Big Data. So, a simple definition of Big Data can also be given as the data which is big is called as Big Data, but how big is the question, right? So, here any data which cannot be handled or which is beyond the processing capacity of the existing infrastructure can be called as big data. So the definition is any data which is beyond the processing capacity, which is beyond the processing capacity of existing hardware or infrastructure, whatever you call it as, infrastructure can be called as big data. That is one of the definitions we have about big data. A lot of people also say that any data which is beyond terabytes can also be called as big data. Now when I say terabyte, that is there are units to measure the memory of the computer. Now what is a terabyte? 1024 GBs is called as 1 TB. Nowadays every computer or every laptop is coming with 1 TB of hard disk capacity. Now let us understand what is the units of memory all about. What are the units of memory all about? So all of you know that 0 or 1 can be called as 1 bit, and bits like this, if they are 8 bits, then we call it as 1 byte. So and 1024 bytes like this can be called as 1 kilobyte, and 1024 kilobytes can be called as 1 megabyte, and 1024 megabytes can be called as 1 gigabyte. 1024 gigabytes can be called as 1 terabyte, and 1024 terabytes can be called as 1 exabyte, and 1024 EBs are called as 1 PB, 1 petabyte, and 1024 petabytes can be called as 1 zettabyte, and so on. It goes on and on. So now 5 years ago, or from now 5 years ago, nobody was aware of even 1 terabyte of data. All are of GBs of data is known to everybody else. Now everyone, when I wanted to buy a laptop, everybody is saying that my hard disk capacity is 1 TB, or I do have an external hard disk which can actually store 1 terabyte of data. So these are the units that we can measure the memory inside a computer. So now everybody in all the companies, the people are started talking about zettabytes of data. So there is a huge lot of data out there in the universe. So any data which is beyond the processing capacity is called as big data, or any data in general which is beyond terabytes can be called as big, because gigabytes can be dealt with. So it is when it is terabyte and beyond terabytes, a little difficulty for the companies or the individual systems to deal with. So anything which is beyond this is called as big data. And according to IBM, what they say is, if any data has got 3 V's, any data which has got 3 V's can be called as big data. In fact, they also say that or 4 V's, 4 V's. Now let us understand what is a V is all about. So any data which has got volume, which has got variety, variety and velocity, and the fourth V is veracity. So these are the 4 V's. If any data, according to IBM, what they say is any data which has got 3 V's or 4 V's can be called as big data. So now we'll talk about what is volume, how much volume data has to be, how much voluminous the data has to be, and what are the variety. So that the very important point is variety. Any data which has got variety on it. So we'll see what are the different varieties of data that the companies are dealing with, what are the different varieties of data that the people are handling nowadays. So we'll understand what are the different varieties of data nowadays the people are handling. So before we understand discussing anything further, what I would like to say is, in this course of Hadoop and Big Data, so first of all we'll understand what is data, what is the history of the data, what are the different platforms were there to handle big data before Hadoop, and what is so importance about Hadoop. So we will understand what is data, and we'll see what is big data, what are the different definitions given to what is big data. So we'll see what are the different definitions of big data, and then we'll move on to the history of Hadoop, or what is Hadoop, who actually developed Hadoop, in this history of Hadoop, who actually authored, who invented Hadoop. So we'll also talk about who inventors of Hadoop, and what is so nice about, or what is so special about, Hadoop. Why does that actually got so much of limelight in IT market? So that will understand. And once you understand the history of Hadoop, why Hadoop, what Hadoop can do, what is so important about Hadoop, or why does it get taken so much of limelight in the market. So we'll understand all these things. So once we understand all these things, we also see the differences between the existing traditional relational database models, which are also handling so much of big data, isn't it? So Rdbms are been there for so long, and they were also handling so much of big data. So what is the difference between the traditional Rdbms and Hadoop? So what we'll see is, what is the difference between Rdbms and Hadoop. So we'll see the difference. So why we are started to migrate, the companies have started to migrate from Rdbms to Hadoop. So we'll see the difference. What are the different things that Rdbms has, and what are the different things that, in addition to Rdbms capabilities, what is that Hadoop has in it. So we'll see everything in detail. And once we got to know all these differences, what we'll say is, we'll try to understand what is the speciality, what is that the 2 things or the 3 things or the 4 things, infinite things that Hadoop has in it. Why everybody is looking at Hadoop, though there are so many other technologies who can also deal with big data, who can also do so much of other things what Hadoop can do, but why everybody is looking at Hadoop is the basic question. So that way we'll understand the existing market technologies, or the difference between Hadoop and the different technologies who claim that we also deal with big data. We also try to understand all those things. So once we understand that, then we'll move on to how to install Hadoop. Then how to install Hadoop. So how to have Hadoop. So what is once we install Hadoop, before that what we'll do is we'll understand what is the file system existing, what is the definition of Hadoop, or what is that the combination Hadoop has, what is that one combination or the different combination that Hadoop has. So when I say Hadoop, the first thing that has to come to everyone's mind is its file system, Hdfs. So we call it as Hadoop distributed file system. Now we know what is Hadoop. We learn what is Hadoop, history of Hadoop. Now what is distributed? We are calling it as distributed. What is the distribution? What is the role of this distribution in this file system? And also we will understand what is a file system. So Hadoop has got its own file system. So if you look at the other operating systems, any operating system in the market or any operating system that you deal with has an operating system, right? So Hadoop also got an file system. Any operating system has a file system. You take Linux, you get a Macintosh, take different flavors of Linux, or you take Windows. Every operating system has a file system. Now the question is, Hadoop also has got a file system. So operating system can have a file system. Here Hadoop also has a file system. That means Hadoop can be called as an operating system. If you ask me the question, I would say yes, Hadoop can be called as data operating system. So Hadoop can be called as data operating system. So what I'll do is I'll call this Hadoop as a data operating system. So isn't it? So any file system or any operating system which has got file system is an operating system. Or if you look at any of the operating systems that we have in the market, each and every OS has a file system. So similarly, Hadoop also got a file system called Hadoop distributed file system. So we'll see what is a file system, what is the different file systems that we have in other operating systems, and what is the speciality of this file system of Hadoop. When it comes to big data, why we are not using the existing operating system? Why we have to go for this big data or Hadoop operating system only? So we'll see what are the internal things that would happen when you store the data on an operating system. In depth, in detail, we'll try to understand about different components of the file system. What is the distribution? Why we are calling it as a distributed file system? Why we are not calling simply Hadoop file system? So why we are calling it a distributed file system? We also understand. So all these things we'll study in HDFS architecture, Hadoop distributed file system architecture. So we have an architecture here. So we call it as HDFS architecture. So in this HDFS architecture, what we'll see is what are the different components that Hadoop distributed file system has. So what are the different daemons that we call, or different processes that we have. So once you install Hadoop on a single machine, or on the laptop existing, then we'll understand the different components that Hadoop has in that, or the different daemons. Now here in this again Hadoop, the new version of Hadoop, there are two versions now, 1x version and 2x version. So we also understand the difference between two versions of Hadoop. So Hadoop 1.x or Hadoop 2.x. These are two different versions. The latest can be called as Hadoop 2.x version, in which there are certain processes which have been replaced by. So we'll see what are the different daemons or the processes Hadoop 1x has, and also the different processes that Hadoop 2x has. So we'll do 1.x installation as well. We also do the 2.x installation. So we'll see what are the different processes that are actually have come and in this Hadoop. Now here, so once that is done, we'll see what is Mapreduce. We'll see what is Mapreduce. So in this Mapreduce, we'll see what is a Mapreduce. So what is the role of this Mapreduce in Hadoop? So we have a file system, and also I am saying we have something called as Mapreduce. So Hadoop is equal to, we have Hdfs and also Mapreduce. Now first of all, so we'll see what is Mapreduce. So we'll also see what are the different things that we'll learn when we are learning Mapreduce. So what is a map? What is reduce? Why? How you define a Mapreduce? You call it as a programming paradigm, or you call it as something else. We'll understand what is Mapreduce. So when we are dealing with Mapreduce, what are the different functionalities that Mapreduce has? In which we'll talk about maps, we'll talk about reducers, we'll talk about partitioner, we'll talk about reducer, map side joins, different joins that we have in Mapreduce, and also we'll see how a map would work on the data, or how a reducer would aggregate the data and give us the final output. In between, are there any different functions that actually come into picture, such as partitioners or such as combiners? What is the role of the partitioners in the combiners? And once we understand that, we look at what are the different joins that we have in Mapreduce. So not only that, how you make your process a little faster, or what actually happens when you run a Mapreduce program on the cluster, or when you are trying to process some data using this functionalities, what actually would happen. All these things in detail we'll understand. See, we'll understand in such a way that what are the output that we get, what are the process that we are getting on the screen. Each and every line we'll try to analyze. What are the different, what's happening actually, background of that particular process. We'll try to understand everything. Now once we'll understand Mapreduce, there are also different subcomponents under Hadoop ecosystem called as Hive, Pig, HBase, Zookeeper, Flumes and Swoop. So we'll see how Hive can be handled. What is Hive? Is there any similarity between Hive and SQL, or what are the differences between that you have in Hive and SQL? What are the components that you have in Hive? Under Hive, mainly we'll focus on what are the tables, how do you create a table, what are managed and what are external tables that you have, or how can you create a database, how can you create a table, in which again how you load the data onto that particular table. So and once you create a table, you make it as an external table or an internal table. Now once you make it as an external or the internal table, we also learn how to partition a table. This is a very important topic when it comes to Hive. So Hive is nothing but it's similar to your structured query language. Whoever are very good at SQL can easily learn Hive. Okay, so we'll focus on what are the partitions, how a partition would actually improve the speed of the process. So once we learn what is a partitioner, then how do you partition a table, then we'll focus on bucketing. How do you divide in further to the partitions? How do you divide how do you actually divide your partition or the table further? So bucketing we'll learn. Once we learn the bucketing, we'll focus on user defined functions. See, when I say user defined function, so we'll see the definition of the user defined function. We'll define some function and we'll try to run or create our own call our own functions using a Hive query. So now then comes is your serialization and deserialization. Okay, we also see lot of use cases. Who are all the companies that are actually using Hadoop, and who are all the companies that are using Mapreduce or the Hive and the Pig. Now Pig is one of the subcomponents that Hadoop has, which also can deal with some form of data. So we'll also learn what is Pig. Okay, Pig, and how do you install Pig, what are the different procedures that you can write using Pig Latin scripting. So and these are the certain, how do you what is the difference between Hive, when to use Hive, when not to use Hive, when to use Pig. when not to use pig, when to use Mapreduce, when not to use Mapreduce. Then comes the NoSQL databases. When I say NoSQL, NoSQL, that means the definition of NoSQL is not only SQL, not only SQL. It's not, no is not literal meaning, don't take the literal meaning as no. It is not only SQL. That means it is something else than that. It is something more than what SQL has. So we have certain NoSQL databases. Okay, for example, HBase. HBase is one of the NoSQL databases under Hadoop ecosystem, and we have Cassandra. Okay, which or MongoDB for that matter, MongoDB. So we have all these NoSQL databases which actually have a little very important, because we have Rdbms, relational database models. Again, we are also calling, these are also the databases. So Hadoop has also the databases, and we are calling that databases as NoSQL databases. So NoSQL databases, not only SQL databases. So we'll see how the process is so fast when you compare it to the relational database models and when you have NoSQL database under Hadoop ecosystem. Okay, so the best thing, the backbone of Hadoop, learning Hadoop, or if you wanted to become a good Hadoop developer, what I would say is the backbone of Hadoop is Mapreduce. It doesn't mean that you need to know you have to be very good at Java. No, that's not my point. Anything happens in Hadoop is Mapreduce. The processor, every process that happens is Mapreduce. So it doesn't mean that you have to be very good at Java in order to learn Hadoop. No, there are certain components like Hive and Pig or databases. Okay, no need for you to actually look at or think of Hadoop. Even 70% of the companies are using Hive. Hive is a query language. We call it as Hive has a query language called HiveQL. If you know SQL, then you can learn or write, do whatever you want to do under Hive. So that easy is what Hive is. So Mapreduce, so when you are looking at Mapreduce, so we will see what are the schedulers that you have, what happens when, because the reason why I am trying to stress on all these things is we are not dealing with small data. What we are dealing with is very humongous and very large data, and we are not dealing with the data which is existing across a network in a single room. We are dealing with the data which is actually spread across different geographical locations. Let us say I'm residing in Hyderabad, my office in Hyderabad. I'm looking forward to do something on my on a machine which is in USA or any other geographical location. So we are not dealing with small data, that's number one. We are not dealing with very closest geographical locations. We are dealing with entire globally located different geographical locations. So Hadoop, in a way, there is a lot that we can learn in Hadoop. There is a lot that we can learn in Hadoop. So we learn or we some of the concepts of Java. We learn Linux, because all the Linux, we call them as POSIX like commands. Almost all the Linux commands can be workable under Hadoop file system. So it has a file system. That is the reason we are calling it as a Hadoop operating system. So this is our data operating system. So this is one important. And we also have Hive. If I don't want to do anything with Java, yes, I can do it the same job with Hive or the same with the Pig. So when it comes to databases, so everybody is so worried about if we do not have databases, how do we go about the humongous data that we have out there in the universe? Then the Hadoop says you don't have to worry about it. You have something called as NoSQL databases. This is a brief introduction that we are going to deal with, and now we'll see again, as I had been saying, what is data all about. Now, what is big data? So big data, as I told you, any data which is beyond the processing capacity of an existing infrastructure can be called as big data. Okay, so or according to IBM, any data which has got volume, variety, velocity and veracity. These three, if any data which has got these 3 or 4 ways can be called as big data. Now, when it is volume, how voluminous is the data in the universe is the question. How voluminous is the data in the universe is the question. So, we have been saying that there is a lot of data out there. Okay, all the companies are saying that yes, we have so much data archived in our servers. Now, so then they say that we are dealing with big data. So, my question to all of you is, what is the use of this big data for the companies, or what is the use of this big data for a common man like all of us? So, what is that I'll get out of this big data is the question. What are the advantages of having big data in the companies, or with the individual person? So, generally speaking, data is something like gold in the companies. If you have data, see, then generally speaking, if whenever we do something or in the companies, we don't talk with the data. If you have data, then only we will talk. So, data is very important in all the companies. So, in fact, you can also hear something called a lot of to grow your business. To grow your business, a lot of people say that customer is the king, right? Now, data has become the king for the growth of a company. So, a lot of people say that customer is the king, but now the data actually replaced the word of the customer with the data. Data has become the king of any company to grow. So, how? First of all, how much data that I have in the universe today? Now, this age can be called this age can be called as the age of data. Age of data. Everything is data driven. Everything is data driven. So, when I buy something, I'll think of the data or data card or the memory card. Why? Because I can store so much of data. So, what happens if I store so much of data? I can do so many things on my laptop or my mobile phone. So much of data is out there in the universe. So, now we are living in the age of data. Now, this data is called as data age. Okay. So, how much data is there? There is an organization called as IDC, which has done a little research on how much data actually out there in the universe, or how much digital data exists in the universe. What they have found is in the year 2006, they did a research on the digital data existing in the universe. What they found out is all the digital data out there in the universe to be 1.8 zettabytes. 0.18 zettabytes. Now, you know what is a zettabyte, right? So, you know what is a zettabyte now. So, IDC has done a research, and what they have found out is the digital data in the year 2006, they found that to be 0.18 zettabytes. It's not terabytes, it's zettabytes. Okay. And again, they did the same research in the year 2011, and what they have found is this data to be 1.8 zettabyte. Now, if you look at, there is a 10-fold increase within a span of 5 years. Within a span of 5 years, it is something like 0.18 to 1.8 zettabytes. Again, what they have forecasted is by the year 2015, it's going to be 16 zettabytes. It's going to be 16 plus zettabytes. So, there is a humongous growth or humongous volume or humongous velocity involved in the growth of the data. Next is what they have predicted or forecasted is by 2020, this is going to be 40 zettabytes, 40, or you make it as 40 plus zettabytes of data. The reason is everything is digital, has become digital, digital in the universe. Let us say we are 5 in the family. Now, all the 5 people have smartphones. or 5 years ago or 10 years ago, we do not have the concept of actually the smartphones. Now all the 5 people of my home do have what? Do have all the emails, or we have, everybody has an account in Facebook. We'll talk a little later about all these things. So now we'll understand this is the order of how data is being increased, or how the data being kind of generating in the universe. That is the reason we are calling this as a age of data. So now there is a lot of data out there. That's well and good. We have so much of data. But what do I do with this data is the question. What do I do with this data? Now the answer is, for example, if you have a cloth store or you have a garment store, you have a garment store. Now every month I buy new garments or new merchandise from other vendors, so that I can fill everything up in my shop. So how do I buy actually? How do an owner would go and buy that particular brand? So every time, every month or every 3 months, what they do is they do some research or they do some analysis on their existing data. So they capture the data. When you go and pay the bill, he'll type in what are the different garments or different the things that you bought from that particular store. So based on the data that they have, what they do, they'll do what is that one product actually sold at a very high pace, or what is that people are liking that particular brand of garment. So he looks at the data and says that this particular garment is being sold at a high rate or whatever, very fastly it's been sold. So he tries to get more of that particular brand and keep them in the store. That means he took a decision based on the analysis he has done. That means he has some data, right? So he did some analysis and he got some information. So based on that information, what did he do? He took some business decisions. He took some decisions which actually can help the organization. So there is a relation between data, analysis, information, and out of that information I can take some business decisions, and out of that business decisions what happens? It will actually help me to generate more revenue to the company. So what do I do with the data is that's what we do. I hope you understand. So data, when analyzed properly, can give us some information. Out of that information, what I'll do, I'll take some different. So any company you take, all the companies work on this. So data cannot be, cannot be lost or cannot be, kept it like that. If you analyze it, then you'll come to a proper conclusions. Based on that, you'll take some business. That's the ground rule why we need data, or what is the use of this big data for the company, in that case for a common man. So there is a lot of data out there, so how to deal with. Okay, now let us see what is variety. So we are saying that a lot of data out there, so voluminous data, very voluminous, voluminous data. Now we'll talk about what is variety. So data has also got variety in it. What are the different varieties or different categories of data that the people are producing, or we are all producing? What kind of different forms of data? Okay. Now, what are the different varieties of data that are produced? Now, let us say I have a Facebook account. So what I do is, once I log into my Facebook account, I can see a lot of things, under my account. I can see, a lot of pictures being uploaded by so many of my friends, or either I see my own pictures which I have uploaded. So that is one. Next is I also can listen to music, that means audio files. And not only that, I can also see or send some videos to all the friends of mine over the Facebook or in the Facebook. That means I can have any form of data in one of the social networking websites. I'm only quoting one of the social network because every boy who is above or below 18 would have a Facebook account, and they do all these kinds of stuff. They upload the pictures, they upload the audio files, they upload the video files, they chat, they upload text, everything they do. So data is not of only one form here. If you understand, Facebook can take any form of data. Now that is a little very interesting. Any file system if you take, that's when the concept of file system comes in. So here Facebook can take any form of file. You upload everything, it will take, it will not give you an error saying that no, I don't upload this. No, it will just take it. That means somebody behind the scene would be there to handle the data that you upload onto the Facebook. That means there should be some file system, or in a way of saying there should be some servers who can actually handle all these forms of data. So there is a variety in the data. For example, if you look at the astronomical websites, or if you look at all the websites or the servers which are dealing with the sensor related data, or else the website which are actually dealing with astronomical relation data, or all this the particular things which actually dealing with the big data. Now we'll see the reason why we are only saying, or the stock exchange for that matter, stock exchange also deal with so much of big data in it, because it has to capture everything what's happening in the market. Based on that they'll give results, based on that the people will invest on, so it's all related to data. Okay, so there is a variety in data. So this data can be categorized or divided into three forms. One is called as structured data, one is called as structured data. We'll see what is the structured data, what are the examples that you have in structured data. We'll see what is semi-structured data, semi-structured data, and we'll see what is unstructured data. We'll see what is unstructured data. So we'll define what is the structured data, what is semi-structured data, what is unstructured data. So before giving you any further examples, we'll just have a definition of what is a structured data. So the name itself says data which has got some structure, can be called as structured data. Semi is half structured, some structured, some are not structured. So they too all called as semi-structured. And one thing, the last thing we have is unstructured data. So any data which has got no form is called as unstructured data. So we also see what is structured data, what is semi-structured data, and what is unstructured data in the future classes. So there is a variety in the data. For example, Facebook, for example, astronomical website, for example, the data, the servers which are dealing with the sensor related data. So there is a humongous variation or variety in the form of data. But now, for example, Facebook can handle all the forms of data. So that's the best thing about the Facebook, or that's the best thing about all the servers who are dealing with the big data. So there is a variety in it. Next, the velocity is the pace at which been growing. I said that 2006 it was 0.18. 2012 it has grown to something else, 2016 it is going to be something else, 2020 it is going to be 40 zettahours. So the pace it is growing is very fast. There is a velocity for this particular data, and there are also veracity. The veracity is something that which actually genuinity of the data, how genuine that particular data is. So we'll also understand what is veracity. So if any data which has got all these 4 V's can be called as big data. So I have a data which is very voluminous and which has got variety, and also the velocity of the data is very high, and also the veracity, the genuinity of data is also there. So variety, volume, variety, velocity, and veracity. If any data which has got these 4, in fact 3 V's or 4 V's, can be called as big data. So data is something, big data is something. Data is maybe small, big data is very big. How big? That's what we have seen here.